So in the last example we defined, well, we went through and calculated the cofactor of a 2 by 2 matrix. Using the general definition of a cofactor matrix, that's over here. Its entries are a certain sign, -1 to some power, times the determinant of the submatrix. And so far we only know how to calculate the determinant of a 1 by 1 matrix, so therefore we can only do a calculation for a cofactor of a 2 by 2 matrix. But anyways, this is what we got at the end of the day, just looking up there. Okay, so we know what the cofactor of a 2 by 2 matrix is. And now with that we're ready to define, so here's the definition. The determinant of a 2 by 2 matrix, say A, so in this case with cofactor matrix C is defined as so the determinant of A, so here let's go back to, I'm going to write it like this to be consistent so you get used to it. So that's what A looks like, and let's say C is entries C1, so C is C11, C21, C12, C22. So there'll be some number, and the way this is defined is it's the number A11, C11 plus A12, C12. So what did I do here? This is sort of like multiplying all the entries, in the first row. So if you just look at you're like doing the dot product of entries in the first row. So you're using the first rows of A and C. Okay, so you're doing A11 is the first entry in the first row, and A12 is the second entry in the first row. So that's what it's equal to. But there are actually 4 different formulas that will give us the same number. So I'm just going to write them all out here. So you can use this first formula that I just wrote down by basically multiplying all the entries in the first row. You can do the same thing if you use the second row. So it's like A21 times C21 plus A22 times C22. So now we're using the second row. Multiply, do the dot product of the entries in the second rows. We can also do the same thing going across the columns. So if we go across the first column, then we have A11 and C11 plus A21 times C21. We can also do the same thing going across the second column, A12, C12 plus A22 times C22. So there are basically 4 different ways of calculating the determinant of a 2 by 2 matrix. So you can expand, these are called expansions across the different rows or different columns. So this is a second column. I'm just going to just going to say second column, or sorry, second, that was wrong. That's second, oh, good grief. Okay. So this first formula here comes from if you just look at all the entries in the first row. This second formula here comes from if you look at the second rows. I don't need these different colors. This one here comes from if you use the first column entries, and this one here comes if you use the second column entries. And it's a fact that they're all the same. So it's important for you to look at this definition and get comfortable with it, because this is how we generalize it. So in order to calculate the determinant of a 2 by 2 matrix A, you first have to calculate its cofactor matrix. And remember, the cofactor matrix is obtained up to sign by calculating the determinant of the corresponding 1 by 1 submatrices. And once you calculate that, then the determinant just comes out this way here. So this is the definition, and so let's see what happens. Since we already know what the cofactor matrix is, we actually get a formula that we can memorize. So let's do an example / obtain a formula. We're going to get a formula that you should memorize. So we've already said that if A is A, B, C, D, then the cofactor matrix C, so it's going to have 4 entries. The signs will be plus, minus, minus, plus. And so the first entry would be the determinant of, if you remove the first row, if you go back to this matrix here, if you delete the first row and the first column, A, B, C, D, so if you delete the first row and first column, then you're just left with a D, so you get a plus D. Over here, A, B, C, D, so now we're looking at this entry here. If you delete all of, sorry, I'm being very careless. If you delete the entry with a C, then you're left with this B, so you get a B here. If you delete the entry that has the B, then you end up with that C. And similarly, if you delete the entry with a D, then you get an A. So that's the cofactor matrix here. So now let's just go and look at the formula. And again, there are 4 different expressions, and we'll confirm that they all give the same thing. So now that we have A and C calculated, we can see that the determinant of A, B, C, D. So if we go across the first, if we expand across the first row, we get A, D plus B times minus C. That gives us B minus C. So that's using the first row. If we go across the second row, then we get minus CD plus, minus CB, I miswrote that. So if we, let me just back it up here. So the formula is all right here. Okay, so to calculate a determinant of a 2 by 2 matrix A, you first calculate its cofactor matrix, which requires knowledge of calculating determinants of 1 by 1 matrices. And then to calculate a determinant of A, you can expand across either rows or columns to get 4 different expressions. So the determinant of A, B, C, D, if you go across the first row, then you multiply all the entries in the first row, so that gives you A, D, and then B times minus C, that gives you minus BC. Or if you go across the second row, that gives you C times minus D, so that's C times minus B, so minus BC, can't write, minus BC plus AD. And of course, these are the same. Or if you go across the first column, then you get A times D, and then you get C times minus B. Or if you go across the second column, you get D times A. Sorry, I can't, misreading everything. If you go across the second column, you get B times minus C, so minus BC, and you get AD. So of course these are all the same. Okay, so typically you're just define this as, so this is something for you to memorize, so memorize the following, that the determinant of a 2 by 2 matrix A, B, C, D is AD minus BC. So that's worth memorizing. So that's how you calculate the determinant of a 2 by 2 matrix. But I wanted us to calculate it using the definition. So again, to calculate the determinant of a 2 by 2 matrix A, you first have to calculate its cofactor matrix, and then the determinant of the A is given by expanding across the first row of the matrix and its cofactor matrix. That's like dot product the first rows together. Or you can go across the second rows, so you dot product the second rows together, or you go across the columns. So there are 4 different formulas for calculating the determinant, but they end up giving you the exact same thing, as you can see in this example here. So that is how we calculate the determinant of a 2 by 2 matrix. But at the end of the day, you get this formula here, which I recommend you simply memorize.